Hello, grade 8. This is your math lesson for page 73, problem numbers 3 through 55, the odds. This assignment is about subtracting of integers, and when you hear that phrase, hopefully a rule jumps into your head. If you look on page 70, they have their version of that rule sitting there, and they say that subtraction is really adding the additive inverse. We've kind of modified that rule. We've been saying all along in grade 6 and grade 7, to subtract, you add the opposite of the second number. But if you look at page 70 in the yellow box, it says to subtract an integer, add its additive inverse. Which leads to the question of what in the world is an additive inverse? An additive inverse is a number that when you add it to the first number, gets you 0. So the additive inverse of 7 is negative 7. What would be the additive inverse of negative 8? Well, it's got to be positive 8 because we're seeking an answer of 0. Additive inverses add up to equal 0. It doesn't matter what they are. If they are each other's additive inverse, then you're going to get 0. But you can think of this rule either way. It doesn't really matter. To subtract, add the opposite of the second number, or to subtract, add the additive inverse of the second number. Either way. Let's look at some example problems. Some of these should be really easy. If I wrote on the board 14 minus 8, you would say 6, right? Because 14 minus 8 is 6. That one's an easy one. We don't even need to apply the rule. Hopefully you've known 14 minus 8 equals 6 since second or third grade. Here's a little bit tougher problem. How do we handle something like this, where the first number is actually smaller than the second number? This would be our first instance today of it being in a situation where it might be wise to use the rule to subtract, add the additive inverse of the second number, or to subtract, add the opposite of that second number. Once you do that, you end up with a three-step rule problem, right? Adding a positive to a negative. We think about their absolute values. 14 minus 8 is 6. Then we think to ourselves, is it going to be positive or negative answer? In this case, it's going to be negative because this has a bigger absolute value than this number, so we share its sign with the answer. Let's try another one. How about negative 10 minus 8? It's actually a pretty easy problem if you apply the rule. If we apply the rule to subtract, we add the opposite of the second number, or to subtract, we add the additive inverse of the second number, because now we've got the adding of two negative numbers. And the rule for adding of two negative numbers is just simply add them, right? How about something like this? 15 minus a negative 5. Again, not too difficult if you apply the rule. To subtract, we're going to add the opposite of the second number, or to subtract, we're going to add the additive inverse of the second number, and we get 20 as our answer. Done with that one. How about this one? Negative 10 minus a negative 7. Again, let's apply the rule. Either to subtract, we add the opposite of the second number, or we add the additive inverse of the second number. It doesn't matter. But we're left with a three-step rule problem, right? Because we're trying to add a negative to a positive. So we think about their absolute values, 10 and 7. We subtract them, we get 3. And now we have to decide, is this going to be a negative or a positive 3? Well, this number has the bigger of the two absolute values, so we share its answer, or share its sign, rather, with the answer. All of this should be reviewed for you, right? Should be reviewed for you. Hopefully you remember this. Thank you. Have a good day. Ask if you got questions.